You might remember back a few days ago, last week, we did factoring of difference of squares. For example, I might ask you to factor 25x squared minus 49. How did we factor 25x squared minus 49? We first looked for a greatest common factor. Is there a greatest common factor other than 1? Unfortunately, no, I don't think so. I don't think 25 and 49 have anything in common. So what did we do after we looked for greatest common factor? We try to do FOIL backward. That's exactly right. And on this one, we notice that we only have 2 pieces. And you should notice something special about these 2 numbers. What do you notice about the 2 numbers 25 and 49? They're perfect squares. 25 is 5 squared, and 49 is 7 squared. And we have x squared here in the middle. So what should happen? When you have something that's a square minus a square, it factors as 2 binomials. And how does that work? It's 5x plus 7, and the other one is 5x minus 7. Very good. And you can just go ahead and do FOIL and check if you want. And the whole idea is by changing this sign in the middle, when you do FOIL, those 2 middle terms are going to factor out. And that was called factoring difference of squares. These are squares, and difference was subtraction. What if I change this problem ever so slightly, and I asked you to factor 25x squared plus 49? You can't. That's exactly correct. If I give you sum of squares does not factor. What do we call something when it does not factor? We call it prime. All right, so watch out for that one. A lot of people will try to tell me that 25x squared plus 49 equals 5x plus 7 times 5x plus 7. But why is that wrong?
There's no 14 in the problem.
Because you get 14 in the problem?
Wouldn't there have to be a 14 if there was plus 7 plus 7?
You're on the right track, but it's not 14, it's not the right number. Do FOIL. What's 5x times 5x? 25x squared. You forgot you have to take the 5x times the 7. So you get a plus 35x. And then on the inside, you get another plus 35x. And then you get a plus 49. So you don't get a 14 in the middle, rather you get a 70x in the middle. So you get 25x squared plus 70x plus 49. All right, well, what we're going to talk about today is similar formulas, except instead of having the difference of squares or the sum of squares, we're going to have sum and difference of cubes. So basically, there are 2 more formulas that you're going to need to memorize, and they look like this. This one, the first one is called sum of cubes, and it has a cubed plus b cubed. So if you have something that's a cube plus something that's a cube, it's going to factor as a plus b. And then the second term will be a squared minus ab plus b squared. And then the other one you need to memorize is called difference of cubes. It looks very, very similar. You have a cubed minus b cubed. Difference means we subtract there. And you get a minus b times a squared plus ab plus b squared. So what's the only difference in those 2 formulas? The signs, the placement of the minus signs. So notice that this one has a minus sign over here, and the second one has the minus sign over there. Otherwise, they're exactly the same. Okay, so these are going to look like this. The directions would be factor x cubed plus 8. You see the word factor, the first thing you look for is a GCF. Is there a GCF other than 1? No, there is not. The next thing you do is you count how many pieces there are. How many terms are there?
2.
There are 2. If there are 2 terms, you only really have 3 choices. If there are 2 terms, it can either factor as difference of squares, sum of cubes, or difference of cubes. Those are your only 3 choices. Does this fit into difference of squares, sum of cubes, or difference of cubes? Sum of cubes. And why is this one sum of cubes? Well, it's got addition, and 8 happens to be a special number. 8 happens to be not a perfect square, but a perfect cube. 8 happens to be 2 times 2 times 2. So this is the same as x cubed plus 2 cubed. What I like to do is I like to take this formula and write it right underneath. So I'm going to write a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And what that tells me is, what I want to do, everywhere I see the letter A, I'm not going to write A, rather I'm going to write X. And everywhere I see the letter B, I'm not going to write B, I'm going to write 2. So my answer is, what's A plus B?
3.
Not 3, because A is X. So it's X plus 2. What's A squared? X squared. A is X. Minus, what's A times B? 2x, because A is X and B is 2, so that's x2. But normally we switch it around and we write 2x. Plus, finally, what's B squared? 4. B is the number 2. 2 squared is 4. Questions on that? Well, I have a question. This thing over here, that's a trinomial. It has 3 pieces. Shouldn't we factor it more? Don't trinomials factor as 2 binomials usually? Yeah. However, if we were going to factor it, how are we going to get the x squared in front? X and x is the only way to get x squared. And how are we going to get 4 on the other end? 2 and 2 or 4 and 1. If I use a 2 and a 2 on the ends, can I get a negative 2 in the middle? No. If I use a 4 and a 1 on the ends, can I get a negative 2 in the middle? No. So does this trinomial on the end factor? No. All right, so I'll give you a little hint on these things. When you use these formulas, this trinomial you get on the end is never going to factor. So you don't even have to try. Okay, I promise you that that will never factor. Okay, how about if I gave you another one of these? How about, I don't know, how about 27x cubed minus 64? Once again, I look at that and I look for a GCF. Is there a GCF other than the number 1? No, I don't think so. The next thing I notice is that there are only 2 pieces, and it's got a minus in the middle. So it either needs to fit into sum of cube, or I'm sorry, it either needs to fit in difference of squares or difference of cubes. Does this fit into difference of squares or difference of cubes? Cubes. What's the big indication that it falls into the cubes pattern? Well, there's 2 things. The numbers 1 and 2. It's got a x cubed in it, doesn't it? Does 27 happen to be a perfect cube? Yeah, it happens to be 3 cubed. So this is, I'm going to write it this way, this is 3x cubed, because 3 cubed would give me the 27, and x cubed gives me the x cubed, minus, is 64 a perfect cube? Yep, happens to be 4 cubed. So that does fit into the cube minus cube pattern. So once again, I like to write it right underneath. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. This time, every time I see the letter A, I'm not going to write A. What am I going to write? Not 3, but you're close. 3x. Every time I see the letter A, I'm going to write 3x. And every time I see the letter B, I'm going to write 4. Okay. What is A minus B then?
3x minus 4.
3x minus 4. Times. What's A squared?
3x.
Now, when you say 3x squared, do you mean that? Or do you mean that? And they are different, aren't they? Because this one is 3x squared, this one is 9x squared, isn't it? Which one's the right one? The 9x squared, the one I'm pointing at, is the correct one. When you go to plug, A is 3x. So when you plug A in, you have to take 3x times 3x, which gives you 9x squared. And that's a very common mistake. People will write 3x squared there. It has to be 9x squared. You've got to square the number also. Very easy to miss that. Plus, what's AB? 12x, because A is 3x and B is 4. So that's 12x plus B squared is 16. And I'm done. Once again, if I want to, I can try to factor this trinomial over here, but I promise you it will never, ever, 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 ever factor. I'm not going to waste my time trying. Questions on that? Okay, so the last thing that shows up in this section is just a general review of factoring overall. So you might be given a problem like 15 a to the 4th plus 25a squared plus, I'm sorry, that's 25a cubed plus 10a squared. 15a to the 4th plus 25a cubed plus 10a squared. How would you go about factoring that? Find the GCF. We always begin by looking for GCF. Does this one have a GCF other than 1? Yes, it does. And it is? Better than 5? Better than 5a? 5a squared. They each have an a squared at least, don't they? So you want to start by taking out a 5a squared. Left over? 3a squared plus 5a plus 2. Am I done? Maybe, but probably not. Why do I say probably not? I have a trinomial here. Trinomials usually factor more. All right, so what I'm going to do again, what I like to do with these is I'm going to write this 5a squared down, and then I'm going to write down my final answer, and I'm going to come off to the side and factor 5a squared, or I'm sorry, 3a squared plus 5a plus 2. I notice that I have a trinomial and the first number is not the number 1, so I know I have to use that grouping process, which takes a few steps. So I like to write this off to the side Just work with this part, and when I get all done, I'll just fill in the pieces. Okay, so how did that grouping technique work? How did this work when this first number was not the number 1? You multiply the first and the last. 3 times 2 is? 6. 3 times 2 is 6. I need to factor the number 6 so that when I add, I get this number in the middle, which is the number 5. Well, I think that's pretty easy. How can I factor 6 to get a 5? 3 times 2. We already kind of had it, didn't we? 3 times 2. So we come back up here, and we write 3a squared, and then we take this 5a and we split it into 2 pieces. We write that as 3a plus 2a, and then I still have the plus 2 on the end. Take that 5 in the middle, split it into 2 pieces. And the reason we want to split that into 2 pieces is now we have 1, 2, 3, 4 pieces. And how do we factor when we always have 4 pieces? Group them. We group them in pairs. So we consider the first pair and the second pair. What's common to the first pair? 3a. And when you factor 3a, what's 3a out? What's left over? A plus 1. Excellent. Very easy to forget the plus 1, but you need 3a times a to get 3a squared, 3a times 1 to get the 3a. Plus, what's common in our second group? 2, and left over? Just a plus 1, not 2a plus 1, because 2 times a gives me the 2a, 2 times 1 gives me the 2. I'm very, very confident I'm doing it correctly because those 2 things match up exactly. If those 2 things do not match up exactly, you know for certain that you made a mistake. When they do match up exactly, you can be pretty certain you haven't made a mistake. That thing is now my common term. I factor that out. I take out a plus 1. And when I take out the 2 things of a plus 1, what's left over? 3a plus 2. Okay, so I'm going to go back up here. I've got the 5a squared. I fill in the a plus 1. And I fill in the 3a plus 2, and there's my final answer. Questions on that? Yes?
It doesn't matter the order you put it in.
It does not matter the order that you put it in. And it kind of looks awkward to me. Personally, I would have preferred to have the 3a plus 2 first. It just looks weird to me. But no, the order that you put it in doesn't make any difference. I just put it in that order because that's the way it came out. But I agree, it does look a little awkward to me. Other questions? All right.